Okay, so we started this in the last video. So we have our pole that is leaning 8 degrees from the vertical towards the sun, so that makes this 98 degrees. And then they told us that this angle here was 43 degrees and the shadow is 22 feet. We are supposed to find the height of the pole. And so we can set up law of sines. So I'm going to use, can I set up the law of sines? Yes. If I'm going to use the 22 though, that means I have to go with the angle opposite at this one. And in order to find that, I already have enough information because I have 98 plus 43, 141. That means that this angle right here is 39 degrees. So that means I can put sine of 39 degrees here equals, and then I have to set up so that I can find x. So x goes on the bottom, goes with the sine of 43 degrees. And so now it's just a matter of cross multiply and divide. So I'm not going to actually wait for that. We'll just know that you can use a calculator, I hope. If you can't, you need to come see me. Okay? Are we okay with that setup?
Yeah, buddy.
All right. So we always pick the side with the angle opposite it. And the side with the angle opposite it. So if we go to the next problem, when it tilts away from the sun, we've got the sun here. It's tilting away now at 8 degrees.
Be acute.
Excuse me?
It's gonna be an acute triangle.
Yep. Okay, so we've got shadow here of 22 feet still. Right? You looking at the problem? This would not be 98, it would be instead 82 degrees because it's leaning 8 degrees away. And then is this still supposed to be a 43 degree?
Yeah.
Okay. So then how tall is that pole right there? Okay, so once again, I need to find this angle up here, but this time it's going to be 82 plus 43, 125. So then what do I get here? 55 degrees? Okay, so if I want to set it up now, Carson, if I want to set it up now, I'll take the sine of 43 degrees over the side that goes with it, x, equals, and then I have a 22 that I can use, so I can use the sine of the angle across from it, 55 degrees, and once again I will cross multiply and divide. Okay. Now we got to talk about the ambiguous case. Do you all have your formula sheet in front of you? If you don't, please get it out. Okay. Now, the formula sheet is going to be important for this because you have something called an ambiguous case. So, if you notice on your formula sheet, do you see where it says the law of sines? Okay, you see where it says law of sines? And then it says when you're told side, side, angle, when you're told angle, side, angle, and when you're told angle, angle, side, then you can use the law of sines. Okay? Side, side, angle. What do we know that from? Side, side, angle. In geometry, if you had, you're trying to prove two triangles are congruent and you had side, side, angle, what would you say? You can't. How do you remember that? Yeah, it spells a bad word, right? Side, side, angle, backwards, spells bad word. Okay, for us, it's still a bad thing. If you get side, side, angle, it's still a bad thing. That doesn't mean you can't do it, though. It just means there might be more work. Okay? So if you're told side, side, angle, and you're given that A and B and angle A, okay, we'll talk about this in a little bit, but that's going to be important, and that is on your formula sheet. Do you see it where it is? So it says law of sines ambiguous, and underneath it says number 1, if angle A, do you all see it, or is anybody even looking at it? If angle A is an acute angle, and in parentheses underneath that it says H equals B times the sine of angle A. Okay, that's going to be really important. You want to remember where that is. Okay, so let's look at why this is different. Okay, so if A is acute, and I'm looking here, right here at this condition, A is less than H. Okay, so that means side A, I'm sorry, I lied. Side A is right here, isn't it? right? Side A is smaller than the height. Let's put the height, I'm going to put the height in red, okay? This is the height of the triangle, right? It goes straight down from the top. So side A I'll put in blue. If A is less than H, I'll make it really drastically less. What happens? It doesn't touch the other side, right? No matter where I put that side, no matter if I put it this way or this way, even straight down, it's never going to touch the bottom. So if that happens, there are no triangles whatsoever possible if side A is shorter than the height. Does that make sense for everybody? You can't have a triangle. So if that happens, if you are told the side, and angle of a triangle, and side, angle, it matters the order of these things, right? Two sides in a row with an angle on the outside of it, okay? Not the angle in between. But if you're told side, angle, and the side A, or the side opposite the angle, is shorter than the height, then you can say there's no triangles, I'm done, no solutions, okay? That's one nice thing. If side A, remember I put H, I'm going to put the height of the triangle in there, in red. If side A is exactly the same as H, what's going to happen? Where's the side going to be? It's going to be right in the same spot. If I were to take this side and try to put it like that, it's not going to reach, right? Because the only way it's going to reach is if it's going straight down. So how many triangles can I get out of this? Just one triangle. Okay? And it's going to be a right triangle. Yep. Now, if A is greater than B, okay? So here's B right here. We don't really care about H in this case. If A is greater than B, I'm going to run out of room, but that means the only way I can put side A down, I need to extend that, right? And then I can put side A on there. It'll have to go out there. Okay, so it's a pretty typical acute triangle. We've got one triangle. And here comes the annoying one. The one that if this happens, you're going to groan and be annoyed. Okay? So I'll put H in there again. Height of the triangle. Straight down. Now, this is A. If A is bigger than H, but smaller than B, then A could go here. Okay? That's bigger than H. It's longer than H because it actually does reach this side, but it's smaller than B. So I have this triangle right here. Okay? But we can also put, let's go for purplish color. A could also, I could take that exact same side and put it right here. And now I have an obtuse triangle put in there. So we actually get two different triangles if we have this situation going on here. So when we have a problem, we actually have to look at A, H, and B and see which situation does it fit. If it fits one of these two, then I just go ahead and do what I normally do with the law of sines. If it fits this one, we cheer and we say no solution. If it fits this one, we groan and we go on with our work, and I'll show you what to do with that. Okay? Now, it also happens if you have an obtuse triangle, okay, that if A is smaller than B, okay, so this is B right here. So if side A is smaller than B, there's no way it's going to get to the other side. There's no triangles. If A is bigger than B, then, wow, you have a triangle. Okay? So the only time that you're really worried about having two triangles is when you have an acute angle. So let's look at an example. Okay, we draw our triangle. It's 42 degrees. So I'll put my 42 degrees in there. Okay. Side B is right here. That's 12 inches. And side A is 22 inches. Okay. So at this point, you should be looking at your formula sheet under where it says law of Sines Ambiguous. Okay. It's an acute angle, right? 42 degrees is an acute angle. And so then now you look at what kind of comparisons do they have. Now I'm noticing that A is bigger than B. So look on there, does it talk about A being bigger than B? On C, A is bigger than B. So what does it say we have? One triangle. So now I know that I don't have to worry about two triangles, and I can go ahead and finish finding the rest of this. And so then we just go on with the law of sines like we normally would. So I can set up and find, let's find this angle here. Okay, so the sine of angle B over 12 equals the sine of 42 degrees over 22. And I actually want you doing calculators on this, so please get your calculators out and practice with me, because this is going to take a little bit more involvement than just cross multiply and divide. Okay, so let's first start off by taking, on your calculator, take the sine of 42 degrees times 12. Okay, so what I've done here, if you were working on a calculator and didn't see that, sine of 42 times 12 is 8.03, and then when I multiply these two, I get 22 sine of B. We're trying to solve for B, so my next step is then to divide by 22. So do that on your calculator, please.
0.36.
Okay, so we get 0.36. Now I have to figure out what B is. So what am I going to do? What kind of math am I going to do to figure out what B is? This is thinking back to previous lessons. I'm going to do inverse. Thank you, Maddie. I'm going to do inverses. So remember what inverses do is it takes what's inside of these and it switches them. So sine inverse of 0.36 equals B. So do that on your calculator, sine inverse of 0.36, and so then we find B is what? 21.1. And guys, it's best that you're not rounding. So when you guys told me 0.36, I'm guessing you rounded, right? So instead of hitting sine inverse of 0.36, you should do sine inverse and have your answer plugged in there, your old answer. It's just best to not round. Okay, now I need to find my other angle. So my other angle I can do just by subtracting from 180, right? So you guys have your calculators out. Why don't you do that? 180 minus 42 minus 21.1. And we get? 1 what?
16.9.
Okay,
I get 0.8.
whatever. Okay, now it's 21.1, so I don't know how you got 0.8.
21.4.
I did the rounding. So.
Oh, okay, so rounding got us in trouble.
Yeah.
Okay, now we still need to find this side right here, so I'm going to set it up. The sine of 116.9 degrees over x equals, and then I personally would use this because it's usually best to use the information you were given originally rather than something that you came up with. We came up with 21.1. We rounded, so that's probably wasn't a good deal. Okay, so it's best to use the information you were given originally. So I'm going to use the sine of 42 degrees over 22. And this one is just like before. You cross multiply and divide, and you've got your x. Okay. Now I want to move on to the next one here. Okay, so I've got 85 degrees. That means that this is still an acute triangle. It's a really almost not acute. It's a bad line. Okay, so it's almost a right angle. All right, so we've got 85 degrees. I know it's not the best. Okay, A is 15, B is 25. Okay, I'm not going to finish it. I'm just going to kind of sketch it in there. Because A is less than B. So do you see one on there where A is less than B? Huh? A is less than B is, it could be D, right? Okay, what are we missing though for D? We're missing H. So we need to figure out what H is to be able to continue on with how many triangles do we have. So do you remember the formula? Where's the formula to tell us what H is?
H equals B sine angle A.
B times the sine of angle A. Okay, that's what the height is. So B is 25, sine of 85. Okay, so will you figure that on your calculator for me?
Give me the page.
Yeah, you can.
What'd you get?
I don't know, I had a pop-up on mine, so it's like.
24.9.
24.9. Okay, so H is 24.9. So H is bigger than A, right? Isn't H bigger than A? This is H, this is A. Is H bigger than A?
Yes.
Okay, so where does that fit on your,
No solution.
No triangle.
it fits with A, doesn't it? All right, so we gotta say no triangles.
Wi-Fi, no triangle.
No triangles is great. Okay,
Could we just put FDB in there?
do you wanna say that louder into the recording?
Never mind.
Okay. Now,
Funny.
on this last one here,
Right, Dad, make it. Yep, that's exactly what it is.
okay, so on this one, we've got 20.5 degrees. B is 31 and A is 12. Once again, we need to figure out the height. Okay, so H equals B, which is 31, times the sine of A, 20.5 degrees. And what does it tell us H is?
We're at 10.856.
10.856. Okay, so if H is 10.856 and A is 12, that means A is bigger than that, right? So A is bigger than H, but it's smaller. Why am I writing it so dumb? H is smaller than A, and A is smaller than B, right? So which one does that match up with?
Two triangles.
Two triangles. So we're going to have two triangles on this one. Okay? So we have, one of the biggest important things is to understand what your triangles are. Okay? So we've got that 12 goes here. So we've got this triangle right here. So what I usually do is I'll redraw that triangle and label it. So 20.5, 31, and 12. And then the other one we have is when the angle or the side A goes over here. And we get this triangle right here. So then I draw that one over here because I'm going to have two different problems that I'll be working on. So this is 20.5, this will be 12, and this is 31. Okay? So now, how do you go about finding these two triangles and what do you do with them? Okay? For the fun part. All right. Are you ready? You are. Good. Okay. So what am I missing? I need to find this angle here, don't I?
Yep.
People? I need to find that angle? The purple angle? Is it purple up there? It's like pinkish, purplish. On mine it's purple, but it changes color up there. Okay, so I need to find that angle right there. So if I set it up, I'll set it up just like I normally do with the law of sine. So sine of 20.5 degrees over 12 equals the sine of my missing angle over 31. Just like before, I'm going to cross multiply. So I've got 12 times the sine of B equals, and then can you guys figure out what this is for me?
Sine 20, that's like 10.
Okay, so that is what?
10.9.
10.9. All right, now I divide.
I'll practice over here.
Divide by 12 on both sides. So now the sine of B equals what? 0.9. Okay, so we have to figure out what B is. So plug that in your calculator. Remember, we do the inverse here. So sine inverse of 0.9 equals B. So what do we get for B?
64.2.
Okay,
64.8.
you didn't round and he did, right?
I didn't round.
You didn't. Okay, listen. 64.2. Now, if we go back to our two pictures, okay, the angle that we're looking at are the two angles that are different, right? We have this one when the side went out to the right, and we have this one when the side went to the left. So the 64.2 is for one of those. Which one do you think it's for? Here's a clue. Our first one is an acute angle. Our second one is an obtuse angle. So 64.2 goes with acute or obtuse? It goes with acute. So that means this one right here is 64.2 degrees. Okay, if you rounded, that's what you got. You shouldn't round though. Okay, now you can finish this triangle just like we would before. Subtract those from 180. And then set up, I hope I don't have to, and then you would set up another law of sines to figure out this one. Let's actually look at what your setup would be. to find what we're trying to find this side. So I'm going to use these guys because I always want to use what I know. So I'm going to go sine of 20.5 degrees over 12 equals sine of whatever angle you found here over x. Okay? That would be how you'd finish that problem. Okay, now here's the fun part. We got to find this angle. If I do set up my law of sines, I'm just going to have the exact same thing here, and I'm going to get 64.2. So now we have to figure out what is this angle right here. It's not 64.2, but I'm going to use that to help me identify what that angle is. Are you ready to learn that? You ready to learn that? Too bad. So law of sines. We've got the law of sines here. Now, we also have the inverse of sine. Now, what two quadrants is sine in?
Those two.
When you do the inverse, sine is in the first and the fourth, right? Okay? So when we found our angle, we found it in the first quadrant. It was 64.2 degrees. Now remember, we were finding the sine of b is 0.9. So sine is positive. Now, because we were doing inverse, it locked us into the first and the fourth, and because it's positive, it was in the first. But we are now, pay attention. We are now, is everybody focusing here? This is the part I'm not going to answer later if you're sitting here confused because you weren't watching right now. This other triangle is talking about where else is sine positive with this as a reference angle. So what other quadrant am I going to look in?
Four.
Sine is positive.
Oh.
Sine is positive.
Second.
Yeah, elimination, huh? It is positive in the second quadrant also. Now we're getting out of the inverse restriction is what we're doing. We're saying where else could it be? Because the inverse isn't doing it for me anymore. Okay? Now, how do we find our angle? We need to figure out what this angle is right here. Well, guess what? Guess what, Dakota? Dakota, guess what? Guess what, Dakota?
You're going to the up.
This angle right here, my reference angle is 64.2. It's going to be at the exact same spot this one was in that quadrant. So I'm going at the exact same angle. So if this is 64.2, what's this guy right here? How do we find that?
This
180.
180 minus 64. And what is that?
115.75.
Oh, 180 minus?
180 minus 64.2.
115.75.
115.8.
Why did we do one?
Oh, is that I thought that was a 2.5. I don't know why. I'm still out of it.
Okay, so 180 minus 64.2 is 115.8.
Where I saw 5 there.
Okay.
I'm saying that I want to be sure. Oh.
No, I'm sorry. Man, you're done.
Stop talking.
They're girls, what do you expect?
Expect them to stop talking. Okay. Now that you have that 115, we can subtract from 180 and the 20.5 and the 115.8.
You're so rude.
Subtract from 180 and we get that angle, and then we can set up law of sines to find that one. Okay?
136.3.
Thank you.
You're welcome.
What's 136.3?
Those two added together.
Oh, they're added together. That makes more sense than the other one.
23.7.
Okay. All right. I don't know why you guys started talking. Stop talking. Stop. Okay.